Section 4.4 homework, 4.4.13. Could it be that smoking actually increases survival rates among women? The accompanying data table represent the 20-year survival status and smoking status of 1,335 women who participated in a 20-year cohort study. We're going to complete parts A through E. So here's our information. First question is asking us what proportion of the smokers were dead after 20 years, and what proportion of the non-smokers were dead after 20 years, and what does this imply about the health consequences of smoking. So we got to use this first part because this represents our contingency table that has a smoking status, smoker, non-smoker, dead, and then alive represent the rows. So the first thing we need to do is we need to total up our columns and our rows. So here, if we add the following here, we're going to add the values of 145, 447, and that's going to give us 592. Okay, and that represents the column for smokers. Okay, next we have non-smokers. So we're going to add 237 plus 506, and then that's going to give us a total of 743. Okay, now we're going to calculate the row for the dead that are smoker and non-smoker. So that means we're going to add 145 plus 237, which gives us 382. And then likewise, we're going to find the row total for 447 and 506. So we're going to go ahead and do that. When we add those together, then we should get a total of 953. Now remember, in the question, it did say that there were 1,335 women that were surveyed. So that means here, you're going to add these two columns, it gives 1,335. Add these two rows, totals will give you 1,335. Okay, now the next thing we want to do is determine the proportion of smokers who were dead after 20 years. So if we want to find the proportion after 20 years, okay, the first thing is we need to look at the numerator. Well, the numerator represents the value of 145. And then what we're going to do is we're going to divide that by the total of 592, which represents the column total. So here is the column total of 592. So 145 divided by 592 because we're dealing with the column that represents smokers. Okay, next. Now we want to find out the proportion of non-smokers who were dead. So now we're looking at the non-smokers column. So how many were dead in that column? Well, we know that there's 237, and we're going to divide it by the total of that column, which is 743, which gives us 0.3189. Okay, now what we're going to do is we're going to round each of those to 3 decimal places. So we get 0.245 for the first answer, and then 0.319 for the second answer. So let's go ahead and take a look here. So the proportion of smokers who were dead after 20 years is 0.245, and the proportion of non-smokers who were dead after 20 years is 0.319. Okay, now the next question says, what does this imply about health consequences of smoking? Well, this implies that it is healthier to smoke because you're getting a lower percentage for the proportion of smokers here. Okay, next, Part B. Part B says the data in the first table do not take into account a variable that is strongly related to survival status, which is age. Now, the data shown in the second table, which is this here, okay, give the survival status of women and their age at the beginning of the study. So, for example, 14 women who were 35 to 44 at the beginning of the study were smokers and dead after 20 years. So that means over here, from 35 to 44, it's saying that you can see here that there were 14 listed here. Okay, so the question is, they want us to determine the proportion of the 18 to 24-year-old smokers who were dead after 20 years. So we're going to be looking at this data here. So in our next data, we want to be able to figure out the proportion. So when we're looking at 18 to 24 years of age, we're looking at the smokers here, and the amount that we're looking at of the smokers in that age group is 3 that were dead. So we're going to go ahead and then highlight that, so it represents 3. Now, the total of that column is taking 3 plus 54. So when we add that column, then we get a total of 57. So when we add those two together, we get 3 plus 54, which gives us 57. And again, we're focusing on the dead column because that's the question it's asking for our next two questions. So for non-smokers in this age group, we have 2. Okay, and so if we add 2 plus 61 there, then we're going to get a total of 63. Okay, so the question is then asking the proportion of 18 to 24-year-old smokers who were dead after 20 years is the following. Well, we know that the proportion we have here is 3. We know that the column total of that age group is 57. So 3 divided by 57 gives us 0.0526. Okay, next, now the non-smokers, and I'll just use that as green here. Okay, the non-smokers we have is 2. Okay, so we know that we have 2 divided by the column total, which is 63, which gives us 0.0317. So let's round both of those to 3 decimal places. So we get 0.053, and over here we get 0.032. So let's go ahead and put in our answers there. So it says here we get the following: 0.053 for the proportion of 18 to 24-year-old smokers who were dead after 20 years. And then we also found that the proportion of 18 to 24-year-old non-smokers who were dead after 20 years was 0.032. Okay, so now before we go on to part C, we need to complete that table because we're going to need the rest of this information. So what we're going to do is we're going to take the value now of the smokers for 25 to 34 that were dead, and then we're going to add the 121 to give us a total of 125. And then we're going to take 6 and then add 6 with 52 to give us 158. Next, we're going to take the next age group of 35 to 44. The amount that were dead is 14. Adding 14 with 95 gives us a total of 109. And then for non-smokers, we have 7. 7 plus 1, 14, gives us 121. Next, the age group of 45 to 54 that were smokers that are dead are 28. And if we add 103 to that, that gives us a total of 131. And then for non-smokers of that age group, we have 13. If we add 13 plus 68, that gives us a total of 81. Okay, next, the smokers that were dead for the age group of 55 to 64 is 52. 52 plus 66 gives us a total of 118. Okay, for the non-smokers of that age group is 42. 42 plus 83 gives us a total of 25. The next age group, 65 to 74, the smokers that were dead in that group is 29. 29 plus 8 gives us a total of 37. And then the non-smokers for that age group is 101. 101 plus 28 gives us a total of 129. And 75 or older, the smokers for that age group is 15 that were dead. So 15 plus 0 is going to equal 15. And the non-smokers of that age group is 66. 66 plus 0 is going to give us 66. Now again, the questions are only asking for the smoking status that were dead. So we're not using the alive column for any particular proportion, but we do need to add it together to get the total of each column. So now the next question wants us to do the following. We're going to use that information to repeat steps in part C, okay, for the remaining age groups to create a conditional distribution by survival status, by smoking status for each age group. So now we're going to create a new table, which is what we have below. And this is going to represent our conditional distribution for survival status by smoking status. So for the age group of 18 to 24, we've already done that. We've taken the smokers that were dead, which is 3, and we're dividing it by the total of 57, which we got 0.0526. And then for the non-smokers, it was 2 divided by the total in that column, which was 63, to give us 0.0317. For the next age group, 25 to 34, we see that the smokers that were dead is 4, and then dividing it by the total of that column is 125 to give us 0.0320. And then for the non-smokers, we had 6, and we're dividing it by the total in that column, which is 158 to give us 0.0379. The next age group is 35 to 44, and the total for the smokers that were dead in that column were 14, and then dividing it by the total in that column of 109 gives us 0.1284. For the same age group, we're looking at the total of non-smokers that were dead is 7, divided by the total in that column of 121 gives us 0.0578. The next age group is 45 to 54, and we can see that the smokers that were dead in that cell is 28, divided by the total in that column of 131, which gives us 0.2137. And then the next, we're going to take this non-smokers in that age group, which is 13, divided by the total in that column, which is 81, to give us 0.1604. The next age group is 55 to 64. The total smokers in that column that were dead is 52, divided by the total in that column of 118 to give us 0.4406. Now for the non-smokers in that age group is 42, divided by the total in that column of non-smokers, which is 125, gives us 0.3360. The next age group is 65 to 74, have smokers who were dead or 29 out of the total in that column, which is 37, which gives us 0.7837. And for the non-smokers of that age group, it's 101, divided by the total of non-smokers in that column of 129 gives us 0.7829. And then for the last one, 75-year or older, for the smokers we had 15, divided by the total of that column of 15, which gives us 1. And then for the non-smokers, we had 66 that were dead in that column, divided by the total, which is 66, which gives us 1.0. Okay, now what we're going to do is we're going to then round each one of them to 3 decimal places. So again, we have 0.053, 0.032, 0.032 here, 0.038, 0.128, 0.058, 0.214, 0.160, 0.441, 0.336, 0.784, 0.783, 1, and then 1. And then what we're going to do is we're going to come in here and then we're going to fill in our information, and there is our conditional distribution for part C. Now for part D, they want us to draw a bar graph of the conditional distribution from part C. So what we're going to do is we're going to go ahead and click on the second open stack crunch here for this information. So we're going to go ahead and do that. And then we're going to create some new columns with the information that we just filled in over here. So what we're going to do is we're going to first create a column that represents age group, but we already have a column that's age group. So now that we have an age group column, now we're going to create a column called smoker, and then a column that's called non-smoker. Okay? And then we're going to fill in the numbers that we got over here. So for smoker, the age group, we're going to go across and then write them all the way down here. So we have 0.053, 0.032, and then 0.128, 0.214, 0.441, 0.784, and then 1. And then for the non-smokers, we're going to fill in the entire row here in that column. So for 18 to 24, 0.032, 0.038, 0.058, 0.160, 0.336, 0.783, and then 1. Okay, and now what we're going to do is we're going to create a bar graph. We're going to go to graph, we're going to select chart, and then go to columns. Now the columns that we want to put over here are the smoker and the non-smoker, and we want the row labels to be in the age group. We want to make sure that we don't have horizontal bars, we have vertical bars that are split. Okay, and then we also want to make sure that the y-axis labeled with relative frequency, and then let's use horizontal lines. And then select compute. And so therefore there is our bar graph. So if we take a look at part A, okay, this looks like it could be a possibility. So the first two age groups looks pretty similar. The next age group looks pretty similar. And so does 45 to 54, and then 55 to 64. But then when we get to 65 to 74, and the 75 or older, it doesn't match our one that we have here. Okay, looking at over here, if we look at B, it doesn't match the first age group or the second age group. And now let's take a look at C. Well, if we take a look at C, it matches for each one. So therefore, there is our bar graph. So it's going to represent C. Okay, and then state the appropriate conclusion. We can say that in almost all of the groups in the bar graph of part C, the smokers, okay, had a higher death rate than non-smokers.